In this video, we will continue working with logarithmic equations. Okay, so from the exercises you have from the activity, we will solve together number 21, number 25, and number 31. You will solve the other three exercises, okay? First of all, for number 21, we see that we have two logarithms. We need to combine them in a single one. So it will look like, because it's an addition, they combine as a product. It will be logarithm base 2 of x plus 7 that multiplies x plus 8, and that will be equal to 1. Next, we're going to rewrite this expression as an exponential form, so that will be 2 to the 1 equal to x plus 7 by x plus 8. Now, the next thing would be to solve this as a quadratic equation, okay? First of all, we will need to multiply these two binomials, and that will be equal to x squared plus 15x plus 56. And as always with quadratic equations, we will make it equal to 0, so that 2 has to be sent to the other side, so that will be x squared plus 15x, 56 minus 2, that will be equal to 54, and that's equal to 0. We will try to solve it by factoring. If we can't factor, then we go by general formula. Okay, by factoring, let's see if we can find two numbers that multiplied will give me a 54, and when I add them, I get a 15. Yes? You found them? Yeah, these two numbers exist. That would be 9 and 6. 9 multiplied by 6 is 54. 9 plus 6 is 15. So we have our numbers. So we will have two answers. X equal to minus 9 and x equal to minus 6. As always, we will have to test these two values to see if they're possible. Okay, so we need to go back to the original one. And if we look at the original logarithm, okay, if I substitute a minus 9 in the first expression, then it will generate a minus 2. So this first answer doesn't work. Okay, now if I substitute a minus 6 here, minus 6 plus 7, that will be plus 1. So that's possible. And then in the other logarithm, if I substitute a minus 6, that will be minus 6 plus 8. That will be 2, which is positive. So this is an answer, and that's correct. Okay? One answer for this logarithm. Now for problem 25, we have natural logarithm of x plus natural logarithm of x plus 2 is equal to 4. First, we combine in a single logarithm. Because it's a sum, we combine it as a product. That will be the natural logarithm of x multiplied by x plus 2. And this is equal to 4. As we have done before, we rewrite this in exponential form. And let's remember that when we have a natural logarithm, the base is e. So what we have here is e to the 4 is equal to x multiplied by x plus 2. Now, then again, this will look like a quadratic equation, and it can be written as x squared plus 2x minus e to the 4. In this particular case, we have no other alternative than using the quadratic formula, okay? Why? Because e to the 4 is not even an exact number, okay? So we will solve it using quadratic formula. And remember, in quadratic formula, we have a, b, and c. A in this case is equal to 1, b is equal to 2, and c is equal to minus e to the 4. Just like that. That's a number, and we use it like that. So let's start just substituting. We have that x will be equal to minus b, in this case minus 2, plus minus the square root of b squared, which is 4, minus 4 multiplied by a, which is 1, and multiply by c, which is minus e to the 4. And all of this over 2. Well, 2a, but a is equal to 1. Okay, we continue working with this. We have minus 2 plus minus the square root of 4 plus y, because we have a minus by a minus, that would be plus. So plus 4 e to the 4 over 2. And then we will have to simplify. In this case, we can try to simplify by doing the following, okay? We're going to factor the 4 inside the square root. So if we factor a 4, we're left with 4 that multiplies 1 plus e to the 4 over 2. We know that 4 does have a square root, so the 4 gets out of the square root as a 2, so that will be plus minus 2 square root of 1 plus e to the 4, which finally, because we have a 2, a 2, and a 2, we can simplify this expression and it will look like minus 1 plus minus the square root of 1 plus e to the 4. Now, that will be the answer in exact value. The only thing is that we are not going to take the negative answer because we cannot have a negative logarithm here. Okay, so we're going to use only the positive answer here. Only positive answer, and this in decimal numbers would be approximately 6.456 approximately. Okay, so that will be the answer to our logarithmic equation. I know this one doesn't look nice. Why? Because the number e is not an exact number, it's a rational number, but there's a way to solve also these logarithmic equations. Okay, let's go to the last one. Okay, this last example looks a lot more difficult than it really is. Okay, let's see. We have logarithm base a and logarithm base a on both sides, and if you see, we only have logarithms. We don't have lonely numbers. Like for example, in exercise 21 we have a lonely 1 here, and then in 25 we had a lonely 4. This complicates things a little bit, but when we only have logarithms, we can go ahead and group all the logarithms on the left, all the logarithms on the right, and apply the formula we have seen before, the one that says logarithm base a of m is equal to logarithm base a of n, then m is equal to n. We saw this in the previous video. So let's see what happens. Let's combine everything in a single logarithm on each side. We have on the left side, we have logarithm base a. Because this is a subtraction, we will combine them as a division. X minus 1 over x plus 6. And this will be equal to logarithm base a on the right of x minus 2 over x plus 3. Now, using the formula, the rule we just saw, the property we just saw, well, the logarithms disappear and we're left with x minus 1 over x plus 6 is equal to x minus 2 over x plus 3. And then, well, we just cross products. So we have x minus 1 multiplied by x plus 3 is equal to x minus 2 multiplied by x plus 6. We only did a cross product. This one that is dividing here, we send it multiplying to the other side. And this one that is dividing here, we are going to send it multiplying to that side, so we can get rid of the denominators. It's the same thing as multiplying by the least common denominator. In this case, it's x plus 6 multiplied by x plus 3. You can do it either way and you will get to the same place. Now, let's rewrite this expression. We will have quadratic equations on both sides. We will have x squared plus 2x minus 3 on the left equal to x squared plus 4x minus 12 on the right. So finally, let's make this equal to 0 in order to solve the quadratic equations. So everything goes to one side, so it will be x squared minus x squared plus 2x minus 4x minus 3 plus 12 equal to 0. So when we combine these two, they cancel each other. Then we have 2x minus 4x, that will be minus 2x. And then we have minus 3 plus 12, that will be plus 9, equal to 0. Finally, let's see, we have minus 2x is equal to minus 9. So x is equal to minus 9 over minus 2. So we would say that x is equal to 9/2, and that would be our answer. 9/2 is exactly 4.5. So let's substitute the value in the original logarithms to see if 4.5 won't produce any negative logarithms or zeros. Okay, let's see. Let's go to the first one. 4.5 here would be equal to 3.5. So that works. 4.5 here would be 10.5, so that also works. Then 4.5 minus 2, that would be 2.5. It's also greater than 0. And finally here, 4.5 plus 3 would be 7.5. So all of them work. So this is our answer. Okay, so that's it for logarithmic equations. See you. Bye.